But what if I don't have any random value for the x? Let me give one example, example number 7. My f of x equals to x, and my second function g of x equals to x plus 1. I want to find its composition, f composed with the g, which can be written as f of g of x. This time I don't want to put any random value for the x, but still I need their composition. How I'm going to compose f of x with the g of x? F of g of x means that I'm going to put x equals to x plus 1. In g of x, I'm going to put x equals to x plus 1 here. Replace g of x by x plus 1. So I will have f of x plus 1. F of x plus 1 means that I'm going to put x plus 1 for the x here, which equals to x plus 1. So x plus 1 is my final answer. As I said, this time I don't have any random value for the x. I want to compose f with the g. Therefore, I'm going to directly put g of x equals to x plus 1, because look, g of x equals to x plus 1. So directly put x plus 1 for g of x here to become f of x plus 1. This f of x plus 1 means that put x equals to x plus 1 here. My f of x, which is f of x plus 1, will be x plus 1. So x plus 1 is the final answer when I composed f with the g. One more example. F of x equals to 2x minus 1 and g of x equals to x squared plus x plus 5. Again, I want to do its composition without putting any random value for the x. To calculate for f of g of x, which means that f composed with the g, I want to replace this g of x, this complete g of x, by x squared plus x plus 5. Because g of x equals to x squared plus x plus 5, just replace the g of x by x squared plus x plus 5. Let me replace g of x by x squared plus x plus 5 to have f of x squared plus x plus 5. F of x squared plus x plus 5 means that put x equals to x squared plus x plus 5. Put this expression for all the x variables for f of x. I have only one x, so just replace x by x squared plus x plus 5. By putting x squared plus x plus 5 for x in f of x, my function will be 2 into x squared plus x plus 5 minus 1. Just replace this x by x squared plus x plus 5. When you simplify the expression at the end, you will get 2x squared plus 2x plus 9. This is gonna be my final answer when I compose f of x with the g of x. One more example, example number 9. G of x equals to x squared plus x plus 1 and h of x equals to x under the root. I want to do the composition of g of x and h of x. So to calculate for h of g of x, which means that h composed with the g. Again, I don't want to put any random value for the x, so I'm going to replace g of x completely with x squared plus 6x plus 1, because g of x equals to x squared plus 6x plus 1. Substitute this expression for g of x here. By putting this expression for g of x, I will have h of x squared plus 6x plus 1, which means that I'm going to put x equals to x squared plus 6x plus 1 for the x in h of x. Just substitute x equals to x squared plus 6x plus 1, which equals to square root x squared plus 6x plus 1. This is my final answer after composing h of x with the g of x. I composed h with the g, not g with the h.